To folks tuning in from around the world for our 5th Breakfast on the Moon event, good morning, good afternoon, and good evening. My name is Joseph Bland, your Zoom host for today's event. I'm joined by my very special breakfast guests, Apollo Mission Control Flight Director Gerald D. Griffin and Dr. Anthony Postian. Jerry was the Gold Flight Director for all the manned Apollo lunar missions and Flight Director during the actual lunar landings for Apollo missions 14, 16, and 17. He was also Flight Director during the somewhat eventful Apollo 13 mission you may have heard of. Tony, like Jerry, began his career in the Air Force. He is the author of 4 books, including 250,000 Steps, which won 7 international and national literary awards. He chaired the recent all-virtual International Space Development Conference, is a regular contributor to Ad Astra, the National Space Society's quarterly journal, and serves as the Society's Director of Communications and Branding. One important note, if you have a question you'd like to ask our 2 panelists, please click on the Q&A button on the bottom of the screen. And at the end of the interview, I'll try to ask as many questions as time permits. Finally, I want to thank all of you around the world for either getting out of bed or staying up past your bedtime in order to join us here as we celebrate a momentous event that happened half a century ago. At approximately this moment, 50 years ago, Apollo 15 was 6 hours and 40 minutes from a splashdown back on Earth. Jerry was in mission control throughout that journey and is here tonight to tell us all about that historic trip from the Earth to the lunar surface and back again. Jerry and Tony, it's all yours until the QA.
Well, thank you, Joe, and welcome, Jerry. Hey, Jerry, there's a lot of things that Joe didn't mention about your career, which kind of make you unique in terms of a flight director. You were an aeronautical engineer. You were a weapons systems officer in the Air Force. He mentioned all the missions you served on. You served on pretty much every Apollo mission as a flight director, but you also did the lunar landings on 14, 16, 17, the launches on 12. And of course, on the launch on 12, you had the lightning strike, which was your first launch, which had to be a joy. You were the director of Johnson Space Center and a movie consultant on Apollo 13, Contact, Deep Impact, and Apollo 18, which we won't get into because Apollo 18 was really a scary movie to me. My first question is this: did we really go to the moon? I mean, wasn't it just a I'm just kidding. So I had to throw that in there because every time I talk to somebody, I always keep bringing that up because our young people watch 6 or 7 videos on YouTube and think it's fact. So let's talk about Apollo 15. Apollo 15 was the it was the first J mission. It was the first time they did some different things than they had prior on the moon, which made it a very unique mission. It was the 9th crewed mission, but it was the 4th landing. So talk about what the J mission meant and how that differed from the prior missions.
Yeah, Tony, the J mission, it was a name that we used for the last block of spacecraft, both the command service module and the lunar module. Those last 3 vehicles were better than the earlier vehicles because throughout the program, we kept developing new ideas. Now, one of the things that 15, 16, and 17 benefited from, and this is kind of a funny one, was from Apollo 13's problem. Because after 13, when we had the oxygen tank explode, we actually added another, not only fixed the oxygen tanks, but we added another one in the command and service module. So it gave us more oxygen and a little more safety improvement. So those J missions had more consumables. You can think of it that way. That's one reason that the EVAs were able to last longer. The second EVA was over 7 hours, very long. And of course, the big change then also on the lunar surface is we had the rover. The Lunar Rover for those last 3 flights really enhanced what I would call exploration. And I want to talk about that later on, but we really did. We had a much better capability. Also you may recall in the service module that Al Worden was continually in orbit while Dave and Jim were down on the lunar surface. He was taking detailed pictures of the moon out of something called the SIMBA, the Scientific Instrumentation Module, which had been added to the service module. So, and then later Al Worden did a EVA on the way home, deepest space EVA ever done, other than the lunar surface. And he retrieved that film, which was very helpful then for later analysis of the moon, but also it kind of tuned up the landing sites for those last two missions. So 15 was a pivot point. And what I wanted to say about exploration, up until 15, we had pretty well been focused on the transportation system, get them out to the moon safely, get them home safely. When we got to the J missions, we really had the capability to focus a little more on why we were going there, and why was because we wanted to explore the moon and understand it. So we went from this almost totally centric transportation focus and get whatever science we could in the process to let's enhance the science now and go get as much as we can, obviously not taking our eye off the safety and transportation ball, but we had gotten used to it. It was starting to get a little more familiar to us, operating at that distance, operating in that environment was so dirty. The crew with all the dust and stuff. I remember on Apollo 12, Pete Conrad's looking at Al Bean and said, "You look like a bituminous coal miner." He was just covered with that lunar dust, which was like flour. But anyway, 15 was a pivot point that I think showed that we could go stay on the moon for extended periods, not as long as we want to eventually, but and we really did get into exploration.
Well, thank you. So a couple of things I need to point out is if my signal's a little choppy, it's because I happen to be at the highest elevation city in the country. I'm in Leadville, Colorado right now. I'm technically on vacation week. On the flip side of that, I also noticed the NSS Pioneer Award sitting behind you, Jerry, which
Right.
I had the honor of giving you at ISDC 2019. So nice to see that on there. So my understanding is during the flight to the moon, Apollo 15, they had a couple of anomalies they had to deal with, right? There were a couple of issues that came up. Talk about those a bit.
Yeah, I guess the most serious that we had on the way to the moon, a little bit like Apollo 14, short of the abort switch, which some people will remember. We had a problem with the service propulsion system. Engine light came on inadvertently, just came on. And it turned out that switch, which we got back, had a fault in it. But had we not figured out what that was, and that was done by the guys in the back room. I mean, this was really the engineers at the Johnson Space Center and the Rockwell people that built the spacecraft figured out that it was a short in the switch and not a signal to the engine. But if we hadn't figured that out, that would have been a no-go. We would have been no-go for a lunar orbit insertion. We got that fixed. In fact, it gets fixed so quickly and easily that I don't even think the press caught a lot of it. We weren't trying to hide anything. It just happened so fast that, and the guys figured it out in a hurry. That was a big surprise. And then about the only other issue we did, we when we undocked from the S4B, this was the first time that we had sent that S4B stage into the moon intentionally to rattle the seismometers that had been put there on 12 and on 14. And it worked. We impacted the moon with the S4B and it rattled everything and gave the scientists all of that substructure look by that process. So it was a very successful mission, actually pretty clean until we got to the lunar surface. Dave Scott had real problems with the drill and trying to get it into the surface. He finally did it, but it was very, very difficult for him. And they did a marvelous job on the moon. Jim Irwin and Dave had really, really worked hard on the lunar geology. Dave was probably a quasi geology expert by the time we got to the end of the program. And he helped later in the other flights as well. So actually a pretty clean mission in terms of problems. We had to do some mid-course corrections as we normally had to do, both going and coming. And I don't know if you want to get this far ahead, but probably the biggest issue of the entire mission was the fact they lost a parachute on landing back on Earth. And it unreefed, but then it collapsed for some reason. So they landed with only 2 out of the 3 parachutes in the water, and it was extremely hard landing. And so but it didn't hurt anything and turned out just fine. And I don't know if they ever figured out why that chute collapsed, but it did.
Well, I went ahead and cut my video off. That will help my upload versus fighting video. So no one wants to see my face anyway. So I recall though there was one more issue that when I believe that when the lunar and command modules tried to separate in lunar orbit, they couldn't at first. There was a electrical connection or something.
No, what that was, Tony, it was a pressure differential that, as I recall, and it's interesting you bring that up. They did have they had to get the pressure out of the 2 hatches in between, and it didn't happen exactly right. And I do recall that there was a hang up there, but we finally worked around it. And I think that was handled by Gene Kranz, I think, team. And it turned out not to be a big issue, but it gave us a little pause. We had to come back and dock again and kind of reverse that process. And I recall it worked just fine on the second go around.
So let's get before we talk about the Dave and Jim on the lunar surface. Let's talk about Al for a minute. You talked about the sim bay that he had taken all those photographs with while he's orbiting the moon over and over and over and over again. So at one point, the Guinness Book of World Records provided him a world record of being the most isolated human being ever. And it had to do with the orbit that he was flying around the moon. And talk about his orbit, how it was different from others.
Yeah, it was normally the CSM, the Command Service Module, try not to use acronyms, was in a circular orbit. But because of the way they wanted to take these pictures and the way they had designed it, he was in a pretty highly elliptical orbit, a much higher apogee than perigee. And I can't recall exactly the distance, but when he went out to that long, to the high altitude part of the orbit that he was in, he was the most lonesome, far away person in the entire universe that we know of. And so he was, it's funny, Al said it. I remember Mike Collins on Apollo 11 really said it. He said, didn't you feel lonely while you were up there all by yourself and the guys were down on the surface? And he said, no, frankly, I kind of enjoyed it. There was more room. It was quieter. And Mike was saying, I really enjoyed it. Well, Al said the same thing. He said he didn't mind it at all. And all of those guys, the command module pilots were all, when the guys came back up off the surface, they were really surprised at how dirty the guys were. And they wouldn't let them. I remember Dick Gordon on Apollo 12 told the crew, don't you come in here like that. He sounded like a mother telling a kid, get the mud off your feet before you come in here. And but I think Al had probably enjoyed his time alone, and boy, he got way out there, further than anybody else.
Yeah, he told me once that we were talking once about how when he was on the shielded side of the moon, the side of the moon that was dark because the moon was blocking the sun, and there was no light from the Earth. And I asked him how dark it was, and he said actually it was pure white. He said, when you have no light from the sun or the Earth to shield you, space has, because there's so many stars. He said space is just pure white. I mean, he goes, you can't see it from Earth. You can't see it from Earth orbit, but it's just so ridiculously white. He said, I mean, it kind of set him back. He wasn't sure how to respond, how to deal with it when he saw it, because it was just so amazing, which is something that most of us will never ever see in our lives. So now during his EVA, again, we're going to focus on Al for a minute, then we'll cut into the other crew members.
Okay.
On Al's EVA, halfway in between the Earth and the Moon, he had to get out and then do the first ever, deep space, spacewalk basically, and he had to go back and get those film canisters that were back in the sim bay. How long did that take? And talk about that process and how that worked.
Yeah, actually they had to, all the guys had to be suited. They were all back in the command module, but to open the hatch for Al to get out, they had to be suited and pressurized, just like Al was, except they were still, and he was the active guy. They depressurized the cabin and opened the hatch. Now, Dave Scott had done that on Apollo 9. All he did was a stand-up EVA. He didn't get outside the spacecraft. For Al and the sim bay, he had handrails that they had actually added, because you had to have something to crawl out there and hold on to get the panel had already been removed. That was done so that he could take pictures. So the canisters were exposed, but he had to walk out or hand walk out, and he had an umbilical that was tied to him. And he went straight to the first canister and got it, turned around, came back, put it inside. The guys took it and stowed it. His total EVA time, as I recall, was only about 40 minutes, because he walked right through it. He was well trained. He had practiced it. The canisters worked. The film canisters came out right. And he went out there and got them, and he made those trips back and forth, and then came back in. They shut the hatch and repressurized and ready to go.
Yeah, he actually told me that the biggest malfunction of that whole thing was Jim Roman's camera wasn't working right, and he got one shot of him, and not his best side. He said it was a shot from his rear end.
Yeah,
this one big moment of glory, and all he gets is a shot of his rear. He did talk to me at length once about how they set that process up, because he said originally the engineers at NASA wanted to do like this clothesline thing where they went out and hooked them up and they pulled them back from a clothesline type thing. And then Al kept saying that won't work, that won't work, that won't work. So he finally did it in tests, and they found out, yeah, it won't work, because with zero gravity, those things were clanking around and banging on everything. In fact, in one test, it knocked off one of the RCS, just knocked it clean off, so they realized that wasn't going to work. And Al just said, just let me go out and get him and bring him back. I mean, probably the simplest and fastest way.
It's keep it simple, stupid kind of philosophy. And they ended up keeping it simple, and it worked fine. He would go out, he had as I recall, a wrist tether that he would hook to the canister before he removed it. So he wasn't going to lose the canister. And then he would reach down and release whatever it took to get it out. and then he would bring it back. Now, of course, he wasn't going to lose it because he had this wrist tether on it that when he got back to the door, he would take off and hand down to the crew. So Al was, I know he was a good friend of yours. He was also a good friend of mine. He was special. He was ready. Like most of the astronauts, he was a real pro. All these guys had been test pilots. They had done risky things. And he did that with aplomb. He did it really, really well.
Let's talk about Dave Scott. You mentioned Dave did a stand-up EVA during Apollo 9. He also had to do one on the moon during the
yeah, right after they landed. Yeah. Dave had really studied geology. In fact, his primary teacher, or several, but his primary guy was Lee Silver from Caltech. And Lee was the ultimate geologist, probably in the country, one of them anyway. And he had taught Dave that when you get to an unknown region, the first thing to do is to do a panoramic visual, in this case, for a guy doing geology studies in West Texas, for us, but to see what the major features are and to get the lay of the land, any unknown or funny looking things that might pop up. So Dave actually talked the program into doing that stand-up EVA after they landed. It's the only one that was done. It was on Apollo 15. But what he did, he stood on the engine. He and Jim had to pressurize suit, dump the cabin pressure, and they opened the hatch on the top where the docking took place, and opened that hatch, and he stood on the ascent engine cover, and it got him up about this high above the top of the lunar module. So he could look all the way around. And if you go through and listen to that transcript, he describes the major features that he was seeing, some things that surprised him particularly, that sent the lunar scientist off thinking about that, and maybe even modifying a traverse plan to take a look at that big boulder that's shaped funny or something. And so that was a Dave Scott, and it's the only time we did it was 15. But I think it was because Dave had trained so much as a geologist that he thought like they did. And he told me, well, Lee Silver told me that there were a couple of guys in the program, and Dave was one of them. I don't know who the other one was, that if he could get them at Caltech for a semester, maybe 2 semesters, he could qualify them for a PhD. So that's how Lee Silver thought of Dave Scott, that he had really, really studied it. One more story about Dave that I think is important, and that is that when Dave, at the end of Apollo 14, I was just coming off the mission, and Dave told the crowd that he thought we ought to go to field geology training with them. And he was talking about the flight director. He came to me. I had already been named lead flight director. He came to me and said, I think you ought to come out on a field geology trip, our training, and understand how we do it and what we are doing. So I did. I went to New Mexico with them, and it was eye-opening. I learned so much about geology. I was right almost tied on to Lee Silver that whole couple of days. And it really opened my eyes about how they did it, what they went, why they were doing certain things. which we had watched them do in prior flights, but I never had understood the basis for it. Just watched them and understood what they were doing. So I came back to the Johnson Space Center and told Gene Kranz, head of the flight director office. I told Glenn Lunny, another flight director, I said, you guys need to get out there and see how they do this. It will open your eyes. So sure enough, we did. It ended up on 16 and 17. We even had people from headquarters, NASA headquarters, going out and watching these crews train in the field on Earth. And what it did, that's part of that pivot point that I was talking about. It got us all leaning toward exploration as opposed to just transportation, and kind of changed the whole thought process. So, yep, Dave was a dandy, and that stand-up EVA was his idea.
But let's talk about Dave was asked to look for a specific kind of rock on the moon by the geologists. I mean, there was like a prize rock that they were all trying to find on the moon. Talk about that rock, Jerry.
That rock was the anorthosite. How about that? That's a term I'll lay on. Actually, what they were looking for was ejecta, material that had been ejected out of the Imbrium Basin. The Imbrium Basin was formed when a giant something hit the moon when it was still in a molten state, and it blew this stuff out. I think Joe Head just told me it was like 6,000 kilometers. They were looking to try to find that deep ejecta, because that would tell them for sure what the core of the moon looked like and what its age was. Well, indeed, Dave was on the lookout for it the whole time. And if you listen to the transcript on that EVA when they got it, I think it was the third EVA, I can't remember for sure, but he said, oh gosh, he said, I think we found what we came to find. And it was a rock about the size of a football. It was very white. And it was exactly what they were looking for. And I think it dated for about the same age as the Earth, 4.5 billion years. So they called it the Genesis rock. And it's still at the Johnson Space Center in the Lunar Receiving Lab or the laboratory there, where they still are analyzing all those 800 pounds of samples they got from Apollo 800 plus. And the Genesis rock is one of them. And so they found exactly what they were going for. And it kind of made the whole program, you bet, good. And so anyway, that was the Genesis rock.
Yeah, so they were taught to be geologists, and tell me about the transitions, because these guys were all fighter jocks, and I know a lot of them at first didn't really get into the geology piece of this so much, the science part. It was kind of like and they were all test pilots, and they all wanted to fly, and they were all so. But this crew embraced the geology piece of this, and talk about that training process and how they got to that point.
They really did, and I mentioned some of this while you were off the air, but so I won't repeat that piece of it. But all of us in our business, you and yours, have a similarity. I think you hear athletes say when they are asked a question like, you're at the top of your game, what do you want to do next? And they answer, I want to improve. I want to get better. And Tiger Woods said that when he was beating everybody, I want to get better. I think particularly the test pilot, astronaut, wanted to show that they could do something other than just stick and rudder, fly things and that sort of thing. I think there was a natural built-in endeavor in all of them Dave was unique, and he and Jim Irvin, I think, both were unique because they took it an extra step. But if you go back and look how well those guys did their exploration duties, and they had to do it, like you say, kind of starting from a dead stop as a fighter pilot and learn it. I think this is where NASA did a great job of setting up the training, where they exposed these guys to people like Lee Silver at Caltech, and Gene Shoemaker at USGS, and Bill Mulbarger at the University of Texas, all Gordy Swan at the USGS. These were all people that good guys, seldom wore a tie. They were out there, they were field geologists, and that's who they had trained these crews. And so I think, and Dave just took to it extra strong. I think he really wanted to prove that they could be just as good as a geologist sent up there, which of course we did later on Apollo 17. We sent Jack Schmidt, and Jack was a geologist and did a fine job. But I think those fighter pilots were trying to make sure that everybody knew they could do it too, and they wanted to get better.
Well, I know that one of the things I always get asked about is, how did they get that car up on the moon, with the spacecraft? And, that thing was a marvel of engineering. It was kind of like loaded into the side of the lunar module, like an origami, thing that kind of all folds up and sticks in there. And so talk about the Lunar Rover a bit. How it was used the first time in this mission, how they got it there, how it was designed, and it had a problem when they first got it there too. Talk about that as well.
Well, the lunar module really was, as you say, a marvelous design. It had, for one thing, it had to be light anyway, because just for weight to get to orbit and get to the moon. But it also had to get small to be stowed into the side of the lunar module in a bay that was pretty empty. They had to do some moving around, but it had to go in there, and then it had to be deployed. So the thing articulated the wheels, all of it had to come together into a package that would fit in there. And then you had the crew, when they got down on the surface, they pulled a lanyard that let it come down, and as it came down, it unfolded. And it was a marvelous piece of, I drove the simulator down at Marshall Space Flight Center, a 1G simulator. And even it was, I thought was really cool. It was different, easy to steer and all that. Now the Lunar Rover had not only the capability to go great distances, but it could carry things. So their samples, when they picked them up in prior missions, they literally had to either be close enough to get it back to the lunar module, or they had to put it in a pocket or hook it or something on them and carry it with them. They could offload that on the lunar module, and it gave them that carrying capability. They also had to carry all of their tools with them when they were on foot. The rover gave them the capability to carry their tools on the rover. And then finally, of course, it allowed them to get great distance, much farther from the lunar module. Although we always had to protect the walk back distance, because if the lunar module failed, they had to be able to walk back. They may not be able to carry all they'd like to, but they could get back to the lunar rover on their backpack. I'm sorry, to the lunar module with their backpack. The lunar module, or the rover, was delicate. It was, and we had a number of problems over the time we used it. There were times when, and I can't remember, you tell me, was it Dave's flight that the one side of the wheels didn't drive?
Yeah, the front steering. Well, the front steering didn't work on Dave's.
On Dave's flight, there were several of those, so I don't remember all of where they happened. But on that one, they literally lost the front steering drive. But the back kept him going. I guess he could steer. They just didn't have any drive to him. And but 2 flights, guys walked by those fiberglass fenders that would keep the dust from flying up. They were kind of orange colored. If you look at at one of those videos, they would walk by and catch a strap or a piece of their suit or something and tore off the fender. And on 2 occasions, 16 and 17, we had to give them a way to build a fender out of checklist covers and put them on with clips, so at least they would keep from spraying this dust literally over the top of them, which they did. 17, really bad, but they got it. They finally got the fix on, and that helped. But the Rover was a very unique design, built by Boeing, which is not really known for ground vehicles, and it was way before Tesla, and it was electric powered. So it was powered by batteries that that worked well. We never had any issues with that. And the final thing I wanted to say about it was the camera. The camera that was on the nose of the lunar module, we could control it from the ground. We could pan it, zoom it, etc. from the ground. We didn't do that while they were driving. If you see them driving, it's pointed to the front. You can see it bouncing along and gives you a real sense of speed, although the speed wasn't that great. It really feels like they were moving quickly. But when they stopped, then we could take control of we took control of the camera on the ground, and we could pan it around. We could watch them. That's why you could see them. And to this day, I am amazed at the resolution of that camera. If you look back at those videos, it was extremely high def for its day. This is 1971. I don't know how they did it. And we had a rule in the control center that I broke myself. We never put anything on the big displays in the front of the room, like a launch of the Saturn from Earth, because it was distracting. We didn't want people watching these pictures. We wanted them locked onto their data in front of them in the console. So we didn't put that kind of thing. But when we were on the lunar surface, we did, because it had a scientific value. We were actually recording all of that. And when we panned, when they stopped, if the lunar scientists saw something and said, "Can you go back to that and zoom?" they would. So we were using it, so the display was up there. I was fascinated by it. I couldn't keep my eye off of it. And more than once, I had to tell myself, stop it, get back on the data. You got Al Warden in orbit, you got recovery forces, you're making sure that they're going to be in the right position, the carriers and all of that when they came back, and we might have to move them because of weather. There were a lot of things the flight director had going on in his head, but I have to admit, I cheated. I looked at that big display and watched those guys on the surface of the moon, and it was fascinating.
Well, and of course, you mentioned Al's still up there. He's up there doing experiments. So he's operating gamma ray, X-ray, and alpha particle spectrometers, and he's using a laser altimeter, and he's doing all kinds of things up there. Yep. While these guys are walking around the moon. Al used to always joke that he was actually doing all the hard work. Those guys were running around taking 4,000 pictures of each other while they were on the moon. So a typical Al statement.
Yeah.
While Dave Scott was on the moon, he did conduct an experiment of his own. Where he wanted to prove Galileo correct. Talk about that experiment.
That was a neat one. Of course, he had cleared that with Deke Slayton and management and all that, but none of us in the control center knew he was going to do what I'm about to describe. He wanted to prove, Galileo said that an object in a vacuum, no matter what its weight, will fall at the same rate due to the gravity, forces of gravity. But if there's no air to slow anything down, they'll hit the ground at the same time. So, in fact, Dave just told this story in San Diego last week. He said, first thing we had to do, I wanted to get a hammer and a feather. And he had a hammer because the geologists, have hammers that they can hammer away at things, chip rocks and all that kind of stuff. They had a hammer, but they didn't have a feather. So he called a friend of his who was a professor. I know him, named Leo Stockham, called him at the Air Force Academy and said, I need a feather. And I'm thinking maybe a falcon feather, that's the mascot of the Air Force Academy, would be appropriate. And so his contact, Leo, said, okay, let me work on it. And Dave said about a week later or 2 weeks later, he's visited by two cadets from the Air Force Academy, and they indeed have a falcon feather removed from their mascot. And so that was the feather that they took to the moon with them for this experiment. And what he did, he backed up. He also told this story. He and Jim had intended to test this before they showed it to the world. And but they ran out of time, and they were getting short on oxygen. We were trying to get them back in the lunar module, so they ran short on time. So later, he said Jim told him, hurry up. So he backed up against the lunar module, or close to it, and he had his hammer and his feather. And he said, Galileo said that this would work, as you pointed out, and let's see. And he dropped the hammer and the feather. They fell together and hit the surface. He looked down and he said, it worked. And he said that because he wasn't sure it was going to, but it worked. And it was I've used that clip with school kids, even with adults in some speeches. And it is anybody in this audience that hasn't seen it, go find it. I'm sure you can find it in a number of ways, and take a look. It's really an interesting experiment that, and I think Dave and Jim thought of it. Let me stop. Dave just told that story. He and Jim were discussing what could they do to prove something scientific while they were on the moon, and particularly for learning purposes. And it was Joe Allen, another astronaut in the Capcom for his EVAs, who came up with the idea of the hammer and the feather. So it was an interesting story. It was a fun experiment. Go see it if you haven't seen it.
Okay, so I had the honor, I should say, or the experience, we use that word, one time of being at Al Warden's house. And we're sitting there, and after he made me dinner, which was pretty incredible that Apollo astronaut's willing to make me dinner. But after he made me dinner, we sat down in the living room, and The Martian came on, the movie, with Matt Damon. He had never seen it before. And to this day, I wish I recorded that on my phone, that entire experience of watching Al just literally rip that movie to shreds when it came to his engineering and science. I mean, he got so emotional at times. I mean, he would just yell at the TV and said, oh, he would go on and on and on. And I say that because I know you've consulted on a lot of space-related movies. So have you had that experience where you're, on the set of these things and they're doing something that's just blatantly wrong and incorrect, and you chime in and say, wait. So how do you deal with that when you know the facts, and then when you're working with Hollywood and they want to butcher it somehow?
Well, yeah, I've had that happen a number of times, as early as Apollo 13, which was the first film that I was a technical advisor on. But I have to give it to Ron Howard, who was the director. He made it clear from day one, and he must have told me throughout the movie 100 times, I'm not making a documentary. I'm trying to make an entertaining movie that is factually correct, particularly on the technical issues with the flight itself. And let me give you an example. On Apollo 13, when we had try to figure out how to use a square lithium hydroxide canister to scrub the atmosphere over a round hole, we came up with a way to do that. And we used onboard materials that they had, like checklist covers and hoses and duct tape, that kind of thing. Well, there was a group on the ground that sat around the table, literally, with a list of everything they had on board and selected how they thought they might be able to build something that would work. In the movie, and they went and got it, those pieces, those individual, and it came up with a fix. In the movie, the way it happened is the guy that was running that committee came in with this bucket and barrel of stuff and throws it out on the table, and it goes everywhere. He said, "Okay, boys, that's what they got on board, and we got to figure out a way to make something out of all this that'll work." So he dramatized the way they got to it, but he didn't take exception with the way they came out. So it was a creative scheme that I finally got more used to it on that one. Then on Contact, of course, that was fiction. Carl Sagan wrote the book. And on that one, I was a technical advisor, but I was also got in front of the camera. But there was one piece in there that I argued with Bob Zemeckis till he never said shut up or anything, but I put it in writing even. When Jodie Foster was getting ready to go to somewhere, we didn't even know where. That's part of the book, part of the story. This flight surgeon comes in at the last minute and hands her a cyanide pill in a thing. He said, "Now, in case you need this, this is available." And said, "We've done this since the program began." And man, I came unglued. When I read that in the script, I told Zemeckis, the director, I said, "That's not right. We've never used cyanide pills, never been carried." And he said, "Well, Carl Sagan told me you did." And I said, "Well, Carl's wrong." And so he said, "Okay, I'll think about it." And sure enough, when we did the rehearsal, it was in there. I said, "Bob, I thought you were going to take that out." I said, "You can give her a cyanide pill because she's going somewhere she doesn't know, but don't say that it was done since the beginning of the manned space program." And he said, "No," he said, I'm still thinking about it." I said, "Okay." Well, I finally saw the director's cut. It was still in there. So I put it in writing. Still got that letter. And I said, "Bob, this will be the last time I bring it up, but that is wrong. It's not the way it happened." And it's in the film. And so I lost that one. So there are things like that. Now, those later films, Contact and Deep Impact, were fiction. So they wanted it to look right. And they wanted Carl in Contact, since that was based on Carl. And Carl, by the way, died right after we started filming on Contact. So he wasn't there to break this argument between me and Zemeckis. But I finally learned how to use the other side of my brain and get a little more creative. You know, engineers are taught to, you got a problem and you got a solution and you got numbers and you add them up or divide them or subtract them or whatever, and you get an answer. And I finally had to kind of give some of that up and get on the creative side. And I could see what they were trying to do. I understood it better. But there's some glaring errors in everything I've been a part of.
Well, that's just Hollywood. So let's talk about just what's happening modern in modern day real quick before we start taking some questions. The Saturn V, which is just, in my opinion, a marvel of engineering, one of the greatest machines ever designed and built in the history of mankind, stood 363 feet tall, is just generated millions of pounds of thrust, et cetera. So now we have SpaceX's Starship now being stacked up on the pad, and that thing is bigger. It's taller, at least. Not as big in diameter, but it's taller, and it's got more thrust and more power. So talk about your thoughts on modern day, the commercial space sector, and where we're going with it, and what your thoughts are.
Yeah, you said the commercial. I think you misspoke there. The SLS, the Space Launch System.
I mean the SpaceX's Starship on its launch
you're talking about
booster.
the lander. The lander.
Right. They're getting ready to do a launch of this thing on, full scale here. It's
Right.
That, yeah.
Yeah, and that's a big vehicle, but they're having their problems with it. They've blown up a couple down here at the tip of Texas, and but yeah, let me kind of go back to the beginning. Artemis is going to be the next big program. We all know that. Artemis, by the way, is the twin sister of Apollo in Greek mythology, and that's a point not missed. Artemis is going to be, its basic vehicle will be the Space Launch System, which is Saturn class. Saturn V class, size-wise and thrust-wise and lift-wise. They're close, not enough difference to talk about. The difference is it's got those big solid rockets on the side where Saturn was all liquid. And but it's going to have a big launch lift capability, and it will be the way we get back to the moon. And so it's going. The first flight is going to be in November. If everything holds right, it'll be uncrewed, no people on board. It will go to the moon and come back to be the Orion spacecraft to be landed, just like it was in Apollo on parachutes in the water. So that's going good. They're short on funding. In fact, they always will be, and NASA's managing, I think, about as well as they can. Biden administration at least has not turned the spigot off, and that was important because some of us thought they might, but they didn't, and that's good. Now, so SLS, Orion, and some lander eventually will get to the moon. Low Earth orbit. Let's talk a low Earth orbit for a minute. SpaceX has got their Falcon launch vehicle and their Dragon spacecraft. That's what you've seen flown in Earth orbit, gone to the space station, etc. The Starliner is built by Boeing, and it will soon. It just scrubbed the launch, their first launch, because of a problem. But they're going to launch on a ULA, a United Launch Vehicle, and an Atlas, a big Atlas, and they will go to low Earth orbit and go to the space station, just like SpaceX does with the Dragon. So Dragon's already working. I think we'll have the Starliner soon in low Earth orbit. I think ultimately, low Earth orbit is going to be the domain of the commercial sector, hauling people and cargo up into Earth orbit, perhaps to a space station, perhaps to a new space station, perhaps for all kinds of reasons, maybe even sortie missions where a crew goes in orbit for a while to do something. Ultimately, I think that's what the government is going to buy their seats into low Earth orbit, just like they buy a seat on an airline in Washington to fly one of their people to California. They don't have to own the airline. They can actually buy a seat, and it'll be cheaper and easier. I'm all for it. I think the commercial guys that are doing their thing I was trying to encourage, when I was director at JSC, I was trying to encourage the big guys then to put some of their own money up and do some of their own stuff for a bigger return. And they weren't willing to do it. Said it was too risky. So it took a couple of billionaires to come along and fund it. And I think they're doing a great job. They'll be okay. That leaves NASA then to go deep, go back to the moon, go on to Mars. Think about deep space exploration, which I think is fine. We've got to have a lander yet. That's it. We've got the Orion spacecraft, which is very much like the command module that Al Worden flew in with its service module. It's on steroids. It's bigger. It's bigger than the command and service module in Apollo. We don't have a lander yet. They have just the Starship that you mentioned, which is a big, tall lunar lander, much taller than the lunar module, is being developed by SpaceX. And it's a different concept altogether than what we had. Two stages. We had a descent stage and an ascent stage in Apollo. Now we've just got this one big vehicle. Any of you old enough to have seen a movie made in 1950 called The Destination Moon, which was pretty primitive. It looks kind of like the rocket that was in Destination Moon in 1950. Great big round thing and several engines on the base, and it lands, and when it gets ready to take off, it takes off just like it landed. So they've had a little trouble with that. They're trying to do some testing on it down at a place called Boca Chica, which is down at the very tip of Texas, because they could launch out over the Gulf. And SpaceX has a facility there, and they've had some trouble, but they'll probably get it figured out. But you still got to get that vehicle to the lunar surface or to be able to land on. It can't go by itself from Earth. So the SLS has got to take it somehow. And I don't know yet how that's going to work. I don't think it would be at the same time as the Orion. There may have to be a different kind of setup, lunar rendezvous of some kind. Maybe rendezvous is not. You got to get the crew into it eventually. So somehow there's got to be a transfer in there, and I don't understand how they're going to do that yet. But lots of things going on. We got the commercial sector going. We got Artemis going with with NASA and international partners, by the way, and commercial.
So Jerry, here's one of the bone of contentions I know a lot of people have with the Artemis program, and it's one of Elon Musk's bone of contentions too, because there's a lot of Artemis that's very similar to Apollo in that most of what they're doing and using is one-time stuff, right? I mean, you launch it, you use it, it's done. And Elon is coming out with, and been very, very vocal on the fact that that's not sustainable long-term. We can't afford that long-term. We got to be able to use everything over and over and over and over again, which is pretty much what he's been focusing on all his stuff. Even the Starship, that's supposed to go to the moon. He says at least that every part of that ship will be reused, and it can be turned around quickly. So that if there's a flaw of the SLS program right now, it's like a lot of it burns up and it's costly. So how do those come together? I mean, NASA still has, in my opinion, this kind of mindset of Apollo where we're going to build big and we're going to get it up there and get it back. But there's not a lot of economies of scale built into this, so to speak. And yet on the commercial side, because they're business people, they understand that, hey, economies of scale is everything, right? And you got to get your money's value out of it, and you have to get your long-term use out of it, so you can recover your investment. So how do those?
Yeah, I think there's two parts to that answer. We haven't discussed what another piece of this lunar deep space architecture is, something called the Gateway, which that name I don't think really describes it, but what it is, it's a mini MINI space station in lunar orbit at one of the Lagrange points, I think L2, for you guys that understand all that, is at a point where it's essentially fixed with respect to the lunar surface. So the idea would be to take Orion out and dock it to the gateway, take the lander, whatever that is, let's say Starship, dock it to the gateway. And that way, then you could not only service those two vehicles with propellant and all that you'd taken up with the gateway or took it up later, unmanned stuff, and just plug it in and dump some fuel into the storage tank and that kind of thing. That gateway would give you that ability to then start getting at what you're talking about, Tony, and that is that you would stage down to the moon with the Starship, and then you would come back up to the gateway to be refueled and refurbed and put new consumables in it and all that, so that it could be reused again to go down to the lunar surface. Now, the same thing could be done with a two-stage vehicle, although it's a little, I don't quite understand how that would work. But I've been told that you could do the same thing. So if you had this, let me call it a fuel station in lunar orbit, and you in a little habitat where you could rest and sleep, that would be the reusability piece up and down to the lunar surface. You'd still have to carry this heavy stuff out there the first time with something big like the SLS. And indeed, except for the solid rocket casings, it is not reusable. And so the Orion one day may be reusable, but the SLS itself, the core stage, would not be. So are you there, Tony? Or have we lost you again?
I think he's on mute.
Okay.
Well, he's not on mute. I'm not sure what's going on. 8:03, and I think you need to get out of here about 8:30, if I'm not mistaken.
No later than 8:30. I got to be out of here.
So,
So I'm here, and I apologize for my poor connection. I was assured they have good internet here, so apparently they do not. So let's go ahead, Joe, and take some questions to Jerry, since my connection is so poor, and it's 9 o'clock now anyway. So or 9 o'clock my time, 8 o'clock your time.
okay, well,
Some questions with Jerry with the audience.
actually, we don't have a lot of questions yet. I'm hoping that those participants out there would hit the little Q&A button at the bottom of the screen and type in a question. I did have one from Bill Gowan. He's asking, he says, "This is an outstanding discussion. Thank you so much. In addition to the Genesis rock, can you speak to any other scientific discoveries this first J mission enabled?"
I could, if I'd go back and read the science report. They found some funny looking soil that ended up having little beads that contained water inside and they were, as I recall, they were green in color. It was a big surprise, total surprise to the scientists. And later on 17, they found some orange soil that had some of these same kind of beads, except it was orange colored. And so the 15 discovery and the 17 discovery really led them to believe that at one time there was quite a bit of water, had to be, on the moon, particularly in its initial stages, and then as it settled out and cooled, you see the mares. The mare surfaces, like Tranquility Base, where Apollo 11 landed, very level, and that was due to evidently to liquid motion across there. So I really do think that the Genesis rock was probably the biggest one, but every one of the missions had surprises that typical of scientific exploration. It asked more, it ended up asking more, generating more questions than it did answers. And that's why the lunar scientists, every one of them in the world, want to go back to the moon. They want to, for instance, they also want to go to the far side because it appears that the far side is different. It's more hummocky, rolling and kind of leveled off. And they can't quite understand why, because it gets in the sun too. So it's getting the same solar pounding and all that everything else, but it's different. So, you know, and to that question, it's a good one. In all of Apollo, all of the landings, all the exploration we did, and all the samples we returned, it's a teeny baby step on understanding our closest neighbor in the solar system. And I say that as an aeronautical engineer because now I know it. I didn't realize, I thought, man, this is great, you know, kind of when I was doing it. But when we got to those last three missions and I got more on the science side, I learned we had, and even at the end, looking back 50 years now, it's obvious we have just scratched the surface. I mean, we've just begun. And that's why we need to go back and go on farther.
Great. So next question was from Donald Loeb. Have you seen the film Apollo 15 in the Mountains of the Moon? If so, what do you think of it?
I saw that movie some time ago. I haven't seen it recently, but I thought it was excellent. And, you know, the panorama at 15 of that huge canyon and those mountains that were so tall, you don't see it on the TV much, but some of the Hasselblad cameras and all that, the crew, the stills that they took really showed it better, I think. I think the tallest mountain there is 14,000 feet. So it's in that region. And that's one reason we wanted to go there is rugged, but that's what the geologists want. They want that rugged territory so they can see substructures and things like that. By the way, I told you about walking with Leash Silver and glued to his hip as we were doing that lunar geology training with Dave and Jim. And he would keep telling me what I was looking at. They said, you see that slump feature there? And he would point out where you can see strata, different strata, it was slumped on one end. He said, obviously something collapsed and you'd like to get near that collapse so you could understand it. I can't drive through a highway cut now on I-10. We've got some pretty big ones even around here without looking at the strata and looking at it and saying, is that slumped or is it straight or whatever? So it really stuck with me that geology is fun. It's a different kind of thing. And I think Dave and Jim finding that Genesis rock, which is what the question started with a while ago, was a piece of that. It's just amazing stuff.
Thank you. And let's see, Dan Hoy.
And that film, let me say, that film I thought was excellent.
Very good. So Dan Hoy says, sorry, came in a bit late. So it may have been mentioned, but I think I heard once that Jerry is working on an autobiography. Is that true? And any ETA? Thanks for your service.
Well, the answer is yes, I am. A good friend of mine in the ABC News business has been asked that same question several times. And he said, oh yeah, now I've been working on it several years and I've almost got the foreword written. And I have started. I've got a historian writer that is excellent. We're compiling data right now. I've got so much, and I've got so much of it now, thankfully, available in digital form so I can share it with him. We've already outlined the book, and we've gotten the key elements that we want to focus on. But I tell you, one of my problems is is time, and I'm running out of time on one end because of my birthday, and I don't have the time. You've got to sit down and think about this. Like this morning, I'm doing this. I've got another appearance at noon, and not quite as hard to make, and then I've traveled, and I was just in San Diego. I'll be giving a keynote address in Orlando at the Astronaut Scholarship Foundation annual Neil Armstrong Award of Excellence Gala. It's in Orlando this year, not Washington. And so it's one thing after another, and I'm having a hard time getting on. I love it. I love telling the story. I like to share it. I am a little different than some of my colleagues. I have always felt an obligation to the shareholders in the Apollo enterprise, which was all of the taxpayers of the US. And I've always felt an obligation to tell that story to as many of them and as many of their kids and grandkids as want to hear it, because without them, without that public support, we never would have done it. So I enjoy doing these kind of things, but it's taking time from my memoirs. And yeah, actually, my historian says we should call it an autobiography, because I'll be telling the story in my words, but it's going to take some time, and I just hope I don't run out.
I promised Jerry I'd keep this in the interest of time to about 1:15, since I know he's got a busy schedule and a lot to do this morning. So maybe one more question, Joe.
Well, the next one is from Jill Bernardino. It's nice to see a young lady or a woman show up and ask a question. We seem to be an awful lot of guys. What was your favorite Apollo mission and why?
I get that question fairly often. I get it about the missions. I get it about the astronauts. And both of them are a little bit like saying, who is your favorite child in your family? Which one do you think's the best? It's really hard to pick. I can give you the J missions as a group. I thought was the culmination of a long journey. And so they stand out. But I think back after the fire, the Apollo 1 fire, in a lot of countries and a lot of settings, that could have been the end of the program. But to suck it up and fix things, Apollo 7 never gets much credit. We flew that command and service module in Earth orbit for 10.5 days. Had it not worked, the program would have ended. That was my first job as flight director. And I had been a GNC prior to that, Guidance, Navigation, and Control Systems guy. And in fact, was in the control center the night of the fire, getting ready to be a Apollo GNC. And so 7 was a huge step. It just got us going again. And the gutsiest call ever made was Apollo 8. Sending the command service module with 3 people in it on top of a Saturn V that had never had people in it on top of it. And it was right after the last unmanned mission of Apollo, which had 2 very serious failures. Pogo, which surging in the engine, which led to a shutdown and of the rocket. And then we lit the S4B, and trying to continue a test, the S4B, the third stage of the vehicle. And it stopped and it wouldn't reignite. We couldn't reignite it, which we had to do TLI. We had to go through that same sequence, translunar injection. We had to fire that engine twice. So the call to go to the moon on the next flight with those conditions was the gutsiest call made in the entire program by far. And it worked. And for all intents and purposes, although we never focused on the Soviet Union and what they were doing, at least in the ground ops, somebody was, I guess, somewhere. The space race was over. We didn't know it, but the space race was over. So those two missions stand out to me too. And 11, of course, so I can't say what mission was my favorite. It depends on what the context is. And they were all, any of them that got up and got back and didn't hurt anybody and got some results, they were great.
Wonderful. So that's, I guess, the last of our questions. And Anthony, you want to bring this to a close?
Well, I just want to say thanks again, Jerry, for taking your valuable time to spend some time sharing with us this morning. Again, I apologize for my poor connection. I was assured they had a good internet here. They were apparently wrong. And but I hope I got it enough where it made some sense. And
You did.
Jerry, I know you said today you have another one and you're traveling here soon. So when do you start doing Apollo 16 talks and things? Because that's coming next.
Well, we're already talking about that. Charlie Duke, who is the only survivor of Apollo 16 crew, John Young, and well, no, I'm wrong. TK Mattingly's still with us. But Charlie is very accessible, as you know. He's easy to get to. And I've already talked to him about 16 and how we're going to celebrate that. There's some ideas already kicking around. And you'll hear about those, I think, pretty soon. Frankly, I don't know exactly what's going to happen. I think there's a good chance there'll be something going on at JSC on this one. And maybe, Charlie was big in mission control. For 11, he was the Capcom for the landing and so forth. He was with us a lot. And I suspect something at the Cape as well. But I think all of you will be hearing about that pretty soon. And then we got 17. We're already talking to Schmidt about that one because he's the one that's the sole survivor of that crew. And it's not only the 50th anniversary of the mission, it's the 50th anniversary of the end of Apollo, which I think makes it a uniquely important anniversary. And our ranks are thinning, and these 50th anniversaries couldn't come quick enough for a lot of people, and we've missed them. So we like to get them planned and get them going.
Well, I have to say, I want to thank you personally for your having now done 2 of our breakfasts in a row. Definitely inviting you back for 17, number 6 and number 7 breakfast. And it's been wonderful. I'm thrilled. I couldn't be happier. I know the people of the National Space Society truly appreciate your doing this for us, because this is for the people that have tried to support since the mid-70s, really, as much as they can, man's movement into space. So
I know that, and that's one reason I'm glad to do it. Of course, all Tony has to do is ask me to do something, and someday, Tony, I'm going to say no. But I don't know when.
I'm trying not to be too harsh on your time, Jerry. But you have you've been exceptionally gracious. You've been exceptionally gracious. I do appreciate you. Between coming to my event and doing these events and helping me write articles, etc. I do appreciate your time very much so. And thank you again for doing this.
It's always fun working with you.
all right, guys, thanks so much. We're bringing this to an end. Thank you for all those that participated. Bye-bye.
Thank you, Joe. Thank you, Joe.
Yes.